Hello, I'm Mike Wheeler, and today we're going to talk about fire safety. This is week 10 of Safety and Leadership. At the end of this lesson, you should be able to explain what factors allow fires to start and burn. We call that the fire pyramid. List and explain the 5 types of fires, explain what flashpoint is, explain what spontaneous combustion is and how it can happen. List different types of fire extinguishers and explain their best applications, and list and explain methods to prevent fires in the workplace. So in 2020, local fire departments responded to about 1.4 million fires in the U.S. These fires caused 3,500 fire deaths and over 15,000 injuries. Total property damage was almost $22 billion. Most of these are residential fires, but there are a lot of industrial workplace fires that happen as well. So causes of fires, most fires in the workplace are caused by faulty equipment or electrical problems. Open flames, sparks, or embers are the second leading cause, and these are of a particular concern to welders. A lot of times when you hear about a building fire, a lot of times it's people doing work inside the building that end up starting the fire. There was a local case a few years ago that a nightclub venue was burned not to the ground, but was seriously damaged by a fire, and there was HVAC technicians working on the ductwork, and they were cutting the ductwork open with grinders, and the sparks got inside the ductwork and lit a bunch of basically dust bunnies and stuff on fire, and the fire got away from them and did quite a bit of damage to the building. As welders, we're always throwing sparks around, so we need to be really cognizant of all the stuff in the area around us that we could possibly set on fire, and try to keep the area as clean as possible to keep that from happening. And here's an example of fire pyramid. So the fire pyramid is 3 sides: oxygen, heat, and fuel. Fire pyramid represents the relationship between the 3 things a fire needs to start sustain itself: oxygen, heat, and fuel. There are some people that say the fire pyramid actually has 4 sides, and that 4th side is what they call the chain reaction of all that stuff working together. And that may be true. Pyramids, I'm looking at a pyramid right now. It looks like it's got 3 sides, so I'm going to talk about the 3 sides of it: oxygen, heat, and fuel. Now, it's important we know this, because if we know those 3 things, we know how to fight the fire and how to keep them from starting. If I remove any one of those 3 elements, the fire can't start, or if the fire is already going, if I remove any one of those 3 elements, the fire ends. And how we do that depends on our methods. Before the fire starts, we get the fuel out of the area. We clean up after ourselves. We don't let don't let stuff that's flammable collect around the shop, especially welding shops. Once the fire started, we can, usually it's easier to take the heat out of the fire pyramid. We do that with fire extinguishers or water. Some fire extinguishers deprive the fire of oxygen, and that will take one leg out of the fire pyramid and put the fire out that way. So, and again, if we can take any one of those things out, or possibly multiples, we remove the fire. So flammable liquids and flashpoints. So flammable liquids often create flammable gases, so special precautions need to be taken. Flammable liquids should be stored in airtight containers to contain the gases they release and keep oxygen out. So with flammable liquids, the really dangerous part about them isn't the liquid itself, it's the vapor they produce. A lot of times this vapor is heavier than air, so it will collect on the ground and is much easier to ignite than the actual liquid is. Gases can be ignited by a flame or spark at a very low temperature. This temperature is known as the flash point. So flash point is the lowest temperature at which you can get something to light up. And if you look at this little graph here, the flash point of gasoline is 45 degrees below 0 Fahrenheit. So it's releasing enough gas at that temperature, it's still flammable. Look at motor oil, it's up 420 degrees. Peanut oil is 539. That's why they do a lot of deep frying with peanut oil, because it's got a much higher flash point, so it's much safer to use in kitchens. But knowing these numbers will help us, because we want to avoid stuff with really low flash points, because they're much more dangerous. And anything like that we need to keep in sealed containers so the gas can't escape. Remember, low flash point means very high flammability. Types of fires, 5 classes of fires, each is related to the type of the fuel involved. Class A, which is ordinary combustibles, wood, paper, cloth, rubber, some plastics. Class B are flammable liquids or gases. Class C is energized electrical equipment fires. Class D is combustible metals, which hopefully you'll never have to be around. They're incredibly dangerous and they're very hard to fight. Class K, fats, oils, and greases. These are most commonly kitchen or restaurant fires. We need to use correct extinguisher for fire. Using the wrong extinguisher can be very dangerous. So a lot of the Class A fire extinguishers you see in the old days were water. They were actually pressurized water fire extinguishers. They work really good for wood and paper and cloth. Use that on an energized electrical equipment fire. You're actually creating a much greater hazard by spraying conductive material onto this fire, and you can actually be electrocuted by doing that. Same thing with flammable liquids. If you've ever seen somebody try to put out a grease fire with water, as soon as you spray the flaming liquid with water, it just sprays all that flaming stuff around you. You end up with a bigger fire. Combustible metals, there's really the safe way to deal with combustible metals is to cover them in sand, something that will stop the reaction that's causing them to burn. I've got a video in this week's lesson. I've got a video showing combustible metal explosion. And then Class K, it's really similar to the Class B stuff, but they use different chemicals that work better around food products. Types of fire extinguishers. So like fire extinguishers have different classifications, so we use the right one for each fire. And you'll see the classifications on the extinguishers. A lot of times you'll see them that are type A, B, and C, which means they can be on several different types. Again, water is for type A only. Dry powder is the most common stuff you see, which is type A, B, C. Foam is used a lot. It's very good on liquids, not good on electrical equipment. Dry powder is non-conductive, so it works pretty well on that. CO2 works well on liquids and flammable equipment, doesn't work well on paper, normal fires and flammable metals. Then wet chemical, which is the cooking oil fires. You see, they've got this as listed as Class F. Some parts of the world, they use different classification ratings. I believe this is a European standard. But these are the different types of fire extinguishers. Most stuff you'll see in industry are dry powder. Fire and explosion dangers. Gases and some types of dust can create an explosion hazard. When we talk about flammable liquids, often the gas they flash off is usually more dangerous than the liquid itself. These gases have a very low flash point, as we talked about earlier, and if they're in the correct ratio in the air, they can create an explosion when combustion starts. We call that, when we're dealing with ratios of gases to air and their explosiveness or explosive potential, we call it stoichiometry. Every gas that is flammable has the perfect stoichiometric ratio for maximum explosion danger, and we want to stay as far away from that as possible, because what it can do is if that ratio is right, instead of having a fire burn, you have an explosion instead. Some dusts have the same hazards as gases. Grain dust and cornstarch both have a high risk of ignition and high explosive potential. You may have heard about grain explosions, like grain silo explosions, but many different dusts can have similar dangers. Some metallic dusts like aluminum, magnesium, and titanium can be very powerful explosives if they are in the air in the correct proportion. There's a local knife maker that years ago he bought a new grinder. He did a lot of work with titanium. Bought a new grinder, didn't spend the time to hook up the actual dust collection system to it. He just hooked up a shop vac to it, and shop vacs are not designed for that kind of work. Well, anyway, he's grinding away on this titanium. This titanium powder goes through the shop vac's motor, which is not a shielded motor, so there's exposed sparks from the brushes, and lights this titanium dust on fire, and it looked like there was a jet engine blowing out of the back of the shop vac as it burned itself to the ground. Preventing fires. So it's much easier to prevent fires than it is to fight them. We need to keep them from starting. The biggest thing you can do is good housekeeping. Keep your workplace free of fuel sources. Don't put flammables in trash cans or near spark or flame. So if you're throwing away a bunch of paper, don't throw it in the trash can right next to where somebody's welding or cutting. And most of the stuff in a welding shop that gets burned to this is the stuff we bring into it. Cleaning supplies, papers or drawings, aerosol cans. I saw somebody burn up a brand new Carhartt coat, hung it up next to his weld and started grinding. Didn't realize sparks were going right on and ended up setting that thing on fire. Now, most fires start through external or direct ignition, which is, you know, lighting something on fire. An outside factor raises the fuel temperature. Some fires can start through self-ignition or what's called spontaneous combustion. In spontaneous combustion, a chemical reaction, and it's an oxidation reaction, takes place within the fuel, which slowly raises the temperature. If the temperature rises high enough, spontaneous combustion can occur. So because of this, the most common culprit for this is, rags soaked with grease or oil or solvents. Flammable rags must be kept in a metal container with a tight-fitting lid, and that helps keep the oxygen out. So wrap up, fires are a common workplace hazard. We need to be constantly vigilant to keep them from starting. Fires need fuel, oxygen, and heat to operate. If we can remove one or more of these items, the fires cannot start. Fires are classified by fuel type, and this will dictate the type of extinguisher we need to use on them. Using the wrong extinguisher on the wrong fire can be dangerous or even fatal in some situations. Gases or dust can be hazardous. They can ignite and explode if their ratios are in the air right. And again, good housekeeping is the best defense against fires, and this includes the proper storage of oily rags. References. So this has been fire safety. I will see you in class.